Hello folks, we're going to start today this, I don't know how many sessions this is going to take, but we're going to do it one way or the other. We've got a realistic TRC2001, which is the same as the Uniden 100 Audioline 340, that uses the Uniden chassis and has the same snags with capacitors that those now exhibit. The only problem, there's two problems. One, somebody has changed. That's not the right top lid. So somebody has changed the DIN socket for a 4-pin. So that's got to go. 1982 is the date code, so it's a late version. And if we've got a piece of paper, which we should, so it's the 14th of March 26, realistic TRC 2001. I always felt that the realistics, although they're the same as the Audioline and the Uniden chassis sets, they always seem to be better. It's like there was more quality control went into the stuff which was going to be realistic branded. So there we go. Right, that's a bit bizarre, isn't it? Okay, so it's been 80 channeled, which is illegal, so that's got to go, and it doesn't transmit either. So you've got 3 immediate problems. At least it's got the speaker, because 16 ohms isn't going to be very good. So where do we start? Well, I don't even know how that's wired, do I? Because it's just, to me, it's ridiculous. Do you know what it reminds me of? Do you remember when cars all had fitted car radios? Well, the imported cars all had fitted car radios. Back in the day, if you had a British-built car, it was an option, an expensive option. And I remember buying we bought a Nissan Micra, 1984 model, I think it was. And somebody had taken out the factory-fitted car radio, which was a medium long-wave push-button radio, and they replaced it with a radio cassette, which was AM/FM. And what they did was, apart from mar the finish of the car, they took out what was a £60 radio, and they put in what was a £29.99 radio. So then they've got a really rubbish cassette player with a really rubbish radio, which sounded really rubbish, instead of putting up with what was factory fitted. This happens all along. I remember buying a Peugeot car, the radio was missing because somebody had taken out the Philips radio cassette player. They'd put something else in. I went to the scrapyard, I got the Philips correct one from a scrap car. I paid £5 for it, and I had to send it in to have the code decoded, which cost me 18. But at the end of the day, it worked from all these steering wheel controls, and it worked properly. And I tell you what, I've got one of those Datsun type radios. They were, Toyota were doing it too. They were using Fujitsu 10. They were using Hitachi, and they were using Clarion. And one day we're going to look at one of those car radios. We're going to look at these performance figures, and it'll be absolutely astounding. But there you are. People think they get something better. So I think somebody thinks they've done something better there. They haven't. Because realistic are all 5-pin DIN. This isn't, it's not some weird standard. Realistic is the correct standard for realistic. So we'll get this dealt with, and at least I'll take these stupid modifications out, and we'll take it from there. If we can actually unsolder that. Now, at the time, in 1981, I paid £16.99 two tandies for the correct service manual for these, and that's why I can take something as complex as this on. And twofold is my friend Mark G7NDJ actually left his Realistic 2001 with us, and it slowly had parts pinched off it. It was a mistake, wasn't it, leaving a radio with me? It did have a duff phase lock loop chip, so you know the chances of one of those coming up is pretty slim. So the good news is, of course, we can copy Mark's wiring and get this kind of thing put right. I'll try not to let any parts of this run for more than an hour. So we'll either put this into several parts or we'll keep pausing the video. This has come from the trade. They've changed these transistors. They've not been getting anywhere. Part of that problem can be fake transistors, and part of the problem can be something else wrong with it. So I don't want that. And when I send it back, he can have that back because I don't want it. The next problem is what have they done? It's the piggyback job, is it? So TC9106 is the correct one, isn't it? Or is it? I really don't know. We're going to have to get the service manual out to even know what the correct one is. And as it happens, I have a copy of the service manual right here because I had the sense to scan it so we can blow things up and whatever. We've got all the wiring and what colour goes where because I paid £16.99 for this information in 1982. Right, so what I see is the synthesizer, because my memory is like a sieve. So it's TC9119, so that isn't the right one, so that can go back to him as well. So let's hope the phase lock loop chip isn't ruined. I think we have to unsolder this so we get the whole lot out. MPT1320 is quite clear that it may not include other radio frequencies apart from the 40 UK channels. We had to in the UK come up with a higher specification than 2781 to be able to combine the European 40 channels and the UK 40 channels into one set. At the time of MPT 1320, we had in the UK no receiver minimum specification, so we ended up with some pretty shocking receivers like you get in the great sets, you know, the Fidelity Thousands and G-Coils and those kind of things, which we shouldn't have had if there'd been a receiver minimum specification. And then European, it's 6 times, the UK spec of this is 6 times stricter than the American FCC spec on interference on transmit. I seem to recall from my training, and then when we wanted to combine and do 80 channel sets, which eventually came under PR 2797 approval, we had to have improved UK spec, not only to include a receiver minimum spec, to tighten up the transmitter even further. So that was then what was the interim one was PR 2794, which is UK 40 channels with an improved spec. So you'll find that you'll get a set like a Kerno Beta 1100, which may appear as 2781, and then you'll get one which appears a bit later as PR 2794. And it looks the same radio, but when you go inside you'll find the later version's got crystal filters, improved tighter filtering on transmit. So there you go. So this is why it can't be done. and usually it culminates in the phase lock loop chip being ruined, the radio only being very poor performance anywhere. Right, I'll see whether we can unsolder some of this, and we'll probably pause the video, otherwise it goes on and on and on. I need a different pair of glasses. You notice we're not switching it on because we're not going to make the set any worse than it already is. Those of you with a background in electronics will know the avalanche effect of powering things up with faults, especially in CRT televisions. Stupid wires go to what? High low power. Fancy losing that feature. Probably have to take the front panel off to do this properly. I want this doing regardless of how long it takes us. And if it takes 3 sessions and 2 days, it needs doing. So we're just going to open up Mark's one. Oh, that was clever of me. I put all the screws back. I'll just take the top lid off. Mark's got the right lid on his. This has been converted to 80 and then converted back, so but it ruined the phase lock loop chip, which is why it's here. But at least we can follow the wiring. I was wondering whether this capacitor was supposed to be there, and it is supposed to be there, so that's clinched that. Right. Right, that's got the IC out, so we can remove all this other stuff from there. Another point is, if you think you can put these in a socket, you can't. It's not a legal reason, it's not that I'm aware of, but the pins soon tarnish and you're going to get malfunctions. I think we might be best to snip the pins off rather than apply even more heat, and then remove the socket pins . We'll just unsolder the last one. That can go in the box of stuff as well. The sensible thing to do is to now clear up and mend any tracks. Let's see if we can get rid of some of this. Right. So I think the best thing to do is to put some isopropyl alcohol on that so we can actually see what we're doing. Now I've got a scrap Realistic AM illegal radio here, so we'll drill the DIN socket off that. Just clean round these output transistors. I don't often see duff output transistors, you know. It's like 1 in 100 jobs. So it doesn't seem that the customers we normally see have had any SWR issues. The other kiss of death could be some people will put us a crystal filter in. Trouble is then that anybody they're talking to is even the tiniest bit off frequency will sound awful. Right, let's clean that up. Let's attend to links that shouldn't be there. Now it's not that easy because this set's been modified as well. Just looking down here, not sure whether these should be there, and they should. That all looks correct. Yep. So this set here, I'll drill out the riveted on DIN socket, and then we'll just look as to whether it's supposed to be riveted, in which case we'll rivet it back on, or whether it's supposed to be screwed, in which case we'll screw it back on. So we'll do whatever was factory original. (2001). I was telling Mr. Chippie yesterday evening, I said I've got this to do. He says, why don't you start it this evening? I said, I'm already too tired to even think about it. I'm not 20 odd anymore. This one. So it's screwed. Absolutely, we have the proof. It is screwed. So screwed it will be, and the screws are number 37. So 37, and they're self-tappers, 2.5mm and 5mm long. So there we go. That's the horse's mouth. That's what the book of words says. So I'm satisfied we can actually screw this we can actually solder this back in, this IC. Somewhere we have a test jig, and what we've done is to get a scrap Uniden set, and we've actually put a socket in. I'm just saying you can't use sockets, but we've put a socket in it for testing purposes, and it's kind of a test jig for these. But I've actually every faith that this does work, because otherwise the customer would have said, and hopefully we've not damaged it in desoldering. Now a Brazilian supplier has said to me they can supply TC9119s, and by the time I get them, if I buy 100, they'll be 30, just the best part of £30 each, Well, you know what? No one is going to pay £30 for one of these ICs and then the cost of the work as well. So that's why this 80 channel lark, apart from illegal, is the kiss of death to so many of these sets. How can we get that in without an insertion tool? I cut the nail on my thumb yesterday, and that hasn't helped today. Right, if we get the solder, we'll solder that back in. Let's make sure it's pushed in. You want to be aiming at less than 3 seconds of heat on each pin. So before I got to this, the piece of print where my soldering iron is already missing. I think we can just bend that pin over and solder it to where it's supposed to go, like that. So we're going to do the isopropyl again. I've got a brand new one of these in its box, which I bought at the time at $79.99, full whack price. So if all else fails, that would have to come out of storage. Now that storage facility isn't here. So do we look like that's a splendid job? I think we do. We'll compare it again with Mark's. I'm just checking there's a wire link there, and there should be. I'd be good at those spot the difference competitions, wouldn't I? Wow, what's that there? That shouldn't be there. We've got a broken bit of track. It shouldn't be going there. Check my bit of soldering there's okay. Looks it. think that's been cut with a craft knife. Yeah, it has. Not sure why they've linked it across to there, but then I don't know what these naughty modifications entail. So we'll just put a thin bit of wire in there to bridge the gap. The advertisement in the 70s and 80s was bridge the gap with a Cadbury snack. So we'll just take a bit of wire from a bit of chopped off wire. I would do this with the solder pot if I had the solder pot here. Just want to scrape away a bit of the solder mask there, so make sure that we're actually soldering to the track. Not funny they call them tracers in America, but then, you know, as an organ builder we have swell shutters and they have shades. So, and as for automotive differences, they are massive. There we go. We'll check that for continuity. Paperwork to one side. So it goes to there. Check that one I did. Right, so there we go. I'm going to power this up. I think he's already, or somebody at their firm has already changed these 470 and 220 capacitors, which are vital to be changed. In fact, I think this had a full recap, this. So we'll just now take the other lids off marks and make sure that the capacitors are in the right way round. As far as I can see, every capacitor which is the right way round. Oh, it's lost its printed circuit board, hasn't it? So you've got all these chokes on there, and that stops you getting hum and things happening. I think we're going to borrow a bit more of Mark's set here. This is going to be fun to remove. We're going to have to unsolder the socket. It's probably going to be easier to take the screws out. Wrong screwdriver. These are actually countersunk screws, so you can get it in a bit flatter. Right, we'll pause the video while I unsolder this. Okay, so I managed to get the printed circuit board off and I've cleaned the print. We've got no damaged coils or capacitors. So hopefully that goes back in without damaging the print. So some of this I did with a solder sucker, some of it was desolder braid. So it was that way on. And this time we'll screw it in so we've got the mechanical rigidity. So if for some bizarre reason somebody watching thinks they ought to be putting a different socket on, perhaps their favourite mic is wired a particular way, make up an adapter lead instead of ruining the radio. You've lost all that filtering to do that. I'll get that soldered back in, we'll put the wires back on. Right, that's all soldered back in, and the wiring as per the diagram, though we don't have a blue wire, we have an orange wire. No, did we? We're supposed to have a blue wire, and we've got an orange wire on our set, but that goes to the right point. So that's that done. So if I get a Uniden power lead, we'll power this up. What I want to see as I leave this session is I would like to see this receiving now, which is PA and which is external. I'll tell you what, we'll start off in PA unless they've gone and unwired it. Let's hope they haven't. Get that powered up and then we'll get a realistic wired mic. Okay, we're lit up. I'll go and get a mic. We do have receive, thus proving that we've got this phase lock loop operational, which is great news. So we'll do the VCO. I've got no transmit, but that's one of the issues. So we need to determine how much transmit we've got. I've got a sneaking suspicion it's transmitting a bit. So just do the VCO. Shall we connect that to some odd CAN? Yeah. Test point 1 is there. And hopefully you can see that meter. We've got 1.93 on receive, but it's not receive we're looking at, it's transmit. And it was supposed to be on channel 40, so I'll select channel 40. And what we're supposed to have is 3.5 volts on test point 1. We've got 4.1. So I'll keep that keyed. I haven't restored high-low power yet. Ooh, that doesn't feel very good. I don't really want to poke the soldering iron down a polythene core. It's broken, that is. It's broken. Right, so we'll have to take the coil out and see whether we can do anything about that. There you go, another ruined item because of pointless modification. Hopefully we can get this out of the bottom. Right, so that's got that unsoldered. Now the question is, can we get the coil out from this side? At least it's the type that there's a possibility. Now we've got a part number on this. It's an LA16581514. LA16581514. It's always possible that there's AM sets with the same coil in. So we've got to get the crud out of this. Let's see if we can put it in the other way around. Trouble is, it's catching on the crud. So what I'm doing, I'm taking it all the way back out. I've taken it from the top right through to the bottom to clear the crud out of the thread. So now we should be able to pass it through again absolutely perfectly, which we have. So I think we've recovered that, unless it's broken some other way. There we go. Let's see. That delivery that came, I think, is some clipboards. That's going to be well out of lock, isn't it? Yes, Mr. Tango, it is. And there we have 3.5 volts on channel 40. Let's go to channel 1 and see that we have some kind of sensible lock voltage, which we have. I'm going to go to channel 20, make sure we've still got receive. We have. So chances are we've now got a transmitter in lock. It may have been in lock at the wrong voltage before. Was it 4.1 or something? But it's not right, and it's not going to work over the 40 channels in all temperature conditions. Right, next. Right, let's see whether we've got anything happening on transmit. Well, we're drawing 205 milliamps. It's time to get hand portable, and let's see if we can actually hear the thing transmitting out of the VCO. Right, we're on channel 20. Let's key it up. Testing 1, 2, and we have got it transmitting out of the VCO. So that's a good start. So let's see whether we can kind of improve the signal to that and see if we've got any current moving on the meter. Otherwise we'll be moving towards these transistors which have previously been changed. I think that one's broken as well. I think is this transmit or receive? I can't remember on this chassis. Sounds like it's transmit. So at this stage I'm looking for maximum current. It's not how you tune it up as I am at this stage. That appears to be broken as well. Yep, I'll have to get that one out. I'm not going to record every time I have to take a coil out of this radio. We're going to be here forever. So it's this one we're unsoldering. Well, see whether we can get this one out. Do the same again, see if we can get it out to the bottom. We'll do the same. Because we've got the crack bit out, it should go straight through with no debris. There we go. We'll put that in a sensible position and pop that back in. Now this isn't going to suddenly make it transmit because there's something else wrong. Let's plug the mic back in. Power back on. Put suppose I'll walkie back on. That sounds like our tuning point. Move this a bit further away. So as far as I can see, we've now got transmit as far as that first transistor. So now we'll get out the enormous Russian test meter. Right, let's see what we've got. Start at quite a range because there might be a lot of it. No, there isn't a lot of it. The output. Well, we'll start by taking the driver transistor out. Power off at the power supply. Just unhook that capacitor. Check there's no missing components. No missing components. With that disconnecting, I'm going to check there's actually power there. Because this is the one which is the high-low power acts on. Just find where we are. We're here. No, we're not. See what am I doing? We're here. 2028. High-low power, just see where that is. So it's here, the high-low power. So we should have on the power going all the way through there, so we should have full rail voltage at the collector of this transistor. And I'm not bothered which it is, because we should have right there, and then we should have full rail voltage all the time on the collector of the output transistor. So that's two things to check. It could be not transmitting simply because the voltage is missing, because high-low power's been messed with. Let's put an earth on. Put it on my finger instead of the radio. Put the power supply back on. Switch the radio on does help. So we can see we've got the full rail voltage on the output transistor. But we haven't got it on the driver transistor. So let's see where this power goes. We've got it on the high-low power switch, which is linked across. So it's just shorted out at the moment, so it's always on high power is how they've had it. And that's fine for now. But I don't think it's got anywhere else to go to be AWOL. No, it doesn't. So it should be on that coil. It should also appear on that variable resistor. I expect that's high-low power. Let's just see. Yeah, we've got it there on the high-low power switch preset. Well, that looks right, because we've got a current gain of 52, which is what you'd expect. Let's see what number it is. Well, what I'm going to do is I'll solder that back on. I wonder if there's a problem with the insulation. Let's make sure we're absolutely unpowered. To disconnect the heatsink, just in case there's an error there. So we're going to have this in free air just for a moment. And we had this happen on that Realistic 3000 base station belonging to trucking and farming, but it had ruined the transistor. Pull it away. the insulator's missing. Right, I'll power it back up. Straight away, you see that? We're at full scale of the 3 watt range. So, user error unfortunately in the last bit of service work. So let's have a look. Yep, it's quite clearly shown there. Nut bolt and insulator. So look at marks. So same nut and bolt. And I can feel the mica insulator. Right, I'll take the power off. Now we've got here this scrap AM set, so it saves everybody if I pinch the insulator off this, just like that. There we go, that's now bolted up. Right, power back on. Now we've got to transmit power and turn the talkie-walkie off. And you can see that I tuned it up for maximum on the walkie-talkie so I could hear it. We knew it was transmitting out of these early stages. I know we've got the earlier stages somewhere near. Right, I think it's there. I'll just check with the manual, but bizarrely they have you do the receiver first, but it's not my training. So 16, 15, 14, 13, let's have a look. 4. So what does it say? 16, 15, 14, 13, 12. 16, 15, 14, 13, 12, set the power on 10. Here we go. We'll have to go to the other scale because we're already beyond. So about 3.3 watts. .4 watts. You can usually get something near 4 watts out of these sets. There we go, we've got 4 watts. Look at channel 40. No, we're looking at channel 1, 4 watts, 4.0 something, and channel 40, 4 watts. I think it's just slipped a bit over as it's cooled down. Yes, it has. Just drop that a fraction. There we go. So, if I can even find where our sheet is, it's got hoof marks on it now. So it's no TX. Demodify from illegal 80 channel mod. Fit 5-pin DIN socket. Repair whatever that is. L17 and L15. So we had no transmit. It was 205 milliamps. Now we've got 4 watts, 4 watts, 4 watts. We've got low power to do. 987 milliamps. Very, very efficient. Have a quick look at deviation on this test set. While it's actually reading 2.2 on this one at the moment, it was 4.8 and we wanted it, was it 3.5? Yes. So let's have a look at frequency for the first time. 79132, it's still slightly high. It's not adjustable on these. That's brilliant. 2779132. Meter now is supposed to be the centre of the red zone. It's that preset. Is now the centre of the red zone. Meter lamp works, switches have to be done, that's working, that's working, that's working. So let's get a look in at the receiver. Right, we're back with this. We're going to do the deviation. Very, very close. I've got it at 2.2, which is absolutely fine, but we can have it peaking at 2.5 as an absolute maximum. So if I can just remind myself where the preset is. Squelch, RF meter, low power. I've also done the high-low power behind the scenes. Got the wiring back on the switch. Wow! There we go. So I'll bring that back off the test set behind me. Plug it back into the Marconi test set. I've actually got a fault on this new microphone we're using as a test mic. The lead is faulted as it goes into the mic, and this is a new mic. Well, it was new when we set it up a few months ago. I don't expect the test mics to fail as quickly as that, so, and of course we can't get new leads easily, so it's going to be quicker to make up another one than to try and recover a lead off something like a power mic, which is what we keep those horrible power mics for. Right, low power. I'll just check deviation on this test set. Let's go put that on the inset picture. Wallow. There we go, it's exactly the same. That's a good result. So the Marconi test set's deviation meter is working properly today. Right, let's go to the 3 watt scale. And we'll do low power. We'll switch to low power on the front of the radio. And we've got nothing. Now that can of course be because there could be a problem. And it looks like there's a problem. High power, no problem. Low power. Oh, should there be, I wonder if there's a wire missing that, because I've only got 2 wires. No, low power does only have 2 wires. Well, I can only think that the preset's faulty. I'm going to spray it as a temporary measure. But we're going to change it no, it doesn't work. So it's 50, it says 50k. Check that it really is. It's such a, because I got, when I paid £16.99 for this manual, it was a photocopy. It's not ideal. It's RT4. RT4. It's supposed to be 1K. It says so. Right, I think we're gonna break this out. I don't want to damage the print. Now that snapped away without me cutting it, so we did have a broken track. See, this has been swapped before and it's not done the print any good. So why would somebody put 50k in when it's supposed to be 1k? This is another example of why you've got to be looking at what people have fit. I'm going to pause the video and find one. So we get a kit of these from Rapid Electronics, and then we top up from wherever as we need more. These are skeleton presets. They're horizontal skeleton presets. There's no point ever recovering these off scrap radios because they are always knackered. I've asked Mr. Chippie to stay on to do the on-the-air test. We've gone beyond normal time, and I've asked him to make me up another microphone, with us having a problem with this one. I never soldered that capacitor back on. Right, to transmit, we now have something. 400 milliwatts. Back to full power. Very marginally different. There we go. Meter, so on full power, centre of the red zone, it's done, deviation's done, all we've got to do is receive. Shove the link in the mic socket so we can get this done whilst Mr. Chippie does me a, whilst it works, whilst Mr. Chippie does me a new mic. A new mic. Even if I've got to hold it there, that's what we're going to do. Switch to the oscilloscope. Put 100 microvolts on the test set. We're on frequency. This is so good that I don't think we're going to have any requirement to do anything. Very, very slight there. I'm going to do the front end first. I normally do the IF first, only because I'm holding on to this. Spot on. Minute one there. Spot on. Spot on. Put a bit more signal on for these IFs. I'll use the RS tool. That was spot on. And that was spot on. Let's just jot these down. Especially if I knew where the pen had gone. So basically anything better than 1 microvolt's okay. This is very, very good, partly because it's been recapped. 0.36 microvolts, 0.3, 0.94. Let's do the squelch. Squelch to full. I'll show you the attenuator, but I've got a lot of gear in the way. 3, 10, 30, 100, 300. One's a bit more sensitive than that. Squelch is there. That's it. That's exactly it. So that was 300. And it's now 100. Set threshold on the radio. Signal generator to standby. I'll just try that again because it's 1.1 microvolt. It's actually 0.65 if you're careful. S meter is supposed to be S9. At the moment it is a very, very generous 29 microvolts. So we'll now set the signal generator to 100 microvolts and reset the meter. The signal meter is there. And there we are. So we are done. So hopefully the speaker's alright. Okay, so we're ready to put this together. I've soldered the speaker on. The speaker is intermittent. And there's nothing I can do about that because it's 16 ohms and it's square. So they're going to be recovered off a scrap set. It's could be worth buying a scrap AM set in to do that. So there we go. He's probably got more parts than I have. You can see it mess about with the volume control, and I'll put the extension speaker on. And it's, you know, clearly speaker, and it is, because you can touch the speaker, the very thin wire that goes from the terminal on the back of the speaker to the actual speaker itself, and it's you know, you can make it work or not work. These are supposed to be silver screws. I'll just put a couple of screws in. We just haven't got time. You know, we've gone beyond. You know, it's now nearly 8 o'clock in the evening. I've started this at 10 o'clock this morning. I have to have a 10-hour. This is the wrong screwdriver as well. But if we just get a few screws in to hold it together while we do the on the air test. And as I say, these speakers are 16 ohms, they're not 8. There we go. Right, we'll just plug it into our roof aerial. One Anna Roger. There we are. That's the Realistic TRC2001 using the Uniden chassis. Restored back to working order. Thank you for watching.